G'day folks. Well, I was originally going to, I was actually considering retiring the Flamespin, but well, since yet another video got flagged recently, I figure screw it, let's put it to the flaggers and get this old girl running again, and even hotter than ever. So I'm going for another full basic rebuild. I'm going to repair and reinforce the drum. I've got this band which is going to be about here, reinforce the section that tore out. I've just split it with a slitting wheel and pushed it all back together again, and I'm going to tension this band on with a ratchet strap and just tack weld and rivet it to the outer skin of this drum unit. The inner bearing I might repack because it's gotten extremely hot. The outer bearing is still okay. The inner bearing is suffering, it's only got another good run left in it. But we'll see how we go. I mean, this thing's going to get incredibly hot in the next run. I'm going to lean out the fuel even more, get more air in there. I'd say complete failure is quite a possibility because these crimps and welds probably won't hold up to it once it gets that hot. That'll start breaking welds on the inner spider. So it's probably not going to last after another run, but we'll give it another shot. We're heading towards summer, so fire burn's coming anyway. It'd be a good opportunity to look for a laundromat dryer or something, or a washer over the summertime, and make something twice as big. And you know what that means. Twice as many flames. So yeah, let's get welding and building. Alright, well, we're ready to weld. I know it's offset a little bit, but it shouldn't really make much difference. I mainly just want to reinforce this centre section where it's very thin, and as it gets very hot and very soft it's liable to bulge out. Whereas this decent quality steel shouldn't do that, at least at lower temperatures. I do have to watch my EGT, exhaust gas temperature, and actual drum temperature, but if you don't get too carried away it shouldn't blow up. Worst case scenario is this splits its welds, and I will be putting a doubler over that butt joint there, just in case that decides to crack and come apart. But worst case scenario is this will come apart, jam up in the outer casing, and either put so much drag on this the motor just stops, or this will just keep spinning inside it and expand and just lock it up. So there isn't quite enough mass that it would cause a catastrophic failure, like actually exiting the case, but it'd be fairly close to it. It'd be a nasty failure. Lots of sparks. Yeah, anyway, so I'm going to press this down as hard as I can and weld each corner, take the strap off, and then proceed to do a little bit more. Just tack, tack, tack all the way along. It's a very tedious process, but it'll work, and she'll spin again. Might even look at static balancing if I can find some similar or good bearings with the same bore size that I can just mount on the table, and I'll just have it sitting dead horizontal in the open and just see which spot goes to the lowest point, and obviously counteract with little bits of weight I can probably attach from the inside so centrifugal force doesn't try and make them fly off. That, or just weld them to this outer band, little square blocks of steel or something like that, just tack weld them on there. Just try and give it a bit more balance than it already has. Not that I want to go that fast, I just don't want this band to throw it so far off balance I can't even get it to rev up without trying to fly apart. It shouldn't, but it's always possible. This is basically the same procedure I used to make the fan cowling on my rear exhaust fan in the shed. I took a piece of sheet steel about this wide, wrapped it around an old Land Rover tyre with a couple of tie downs strapped around it. I think I pop riveted the top and bottom section and then tacked a couple of spots in the middle, pulled it off the tyre, like had to deflate the tyre to get it to collapse enough to release it, but popped it off the tyre, finished tacking and riveting it, and it was done. It's a very good way of doing it. Wrap whatever you want around a form and then spot and tack it, and you're pretty much right. I don't have any sheet metal rolls, but eventually I want to get some sheet metal rolls, and maybe even an edge roller or a bead roller, something like that. You can have a lot of fun doing sheet metal work like that. Hell, I could even set up there's a $45,000 robot welding cell on eBay at the moment. That'd be kind of fun. It's up in Queensland, and you could even make a Flamespin production facility. Make them all from scratch, laser cut steel, all stainless. I could see Bunnings selling them. Okay, well, about welded on. I haven't put a doubler over that yet, but I'm not 100% sure if I need it now. I've just shored up some of the welds. I mean, I'm welding garbage stainless steel to unknown steel, which doesn't seem to weld like normal black steel. It might be a bit better once it's annealed. This is the same material, and it's certainly a lot easier to work with, but it seems particularly hard. So it's probably a low carbon steel, and it doesn't like being welded very much, but I managed to get enough on there to keep this band in place. And once it gets hot, it'll lose a lot of its tension anyway, so it should be alright. I might even get some 316 stainless steel rivets and just fire 50 of them into it in a zigzag pattern just to help keep it together. I can sort of get to the inside in a few places to put washers on the other side of the rivet. Just have the rivet pull a 3/16 flat washer against the side. That's about it. The paddles, well, they've clearly moved or twisted, but that's all still fairly intact. You can see those welds are starting to push through though. Yeah, centrifugal force has been pretty hard on it. Mind you, it was glowing cherry red when I finally shut it down, so yeah, cherry red and 1000 RPM, that's a lot of stress. Yeah, those angle iron pieces are twisted as well as bent outwards. It suffered a hell of a lot of stress. I think this next run's going to be the last. But I will tap these little edges over with a hammer and just tack them to the outer drum or the outer rotating drum a little bit more. Particularly here. There was a big gap between the drum and this screen before, but I managed to tap it over a bit now that it's soft. When the steel is like that, it's way too hard to really do that without damaging everything else. So now that it's been annealed, it's actually quite easy to work with. Still doesn't weld very well, but that's what you get with low carbon steel. Anyway, I don't have any bearings a second bearing to balance it between two bearings, but this thing seems to spin pretty well, and it's still relatively concentric. I was expecting a lot more radial run out than that, but that's not doing too bad. And that's just sitting on a self-aligning bearing attached to the table. That's pretty good. This thing's holding up. Just got to straighten the outer lip out, peen these edges over and tack them all on in more places. Yeah, it shouldn't fail. These angles are welded thoroughly to the back spider plate, so ultimately this central piece can't really go that far. Worst case is it just starts getting less and less balanced and more soft metal moves over in one direction, and it just can't maintain balance or motor power and just stops. So yeah, catastrophic failure shouldn't be a major risk, but it's always an option. And I do have fire extinguishing systems and decent hoses and other things like that handy, just in case it decides to flip over or part of it decides to escape the outer combustor case. Yeah, could be fun. There's no such thing as fun without risk. Even if it's the most minor of things, like playing with a computer. There's always the risk you could zap yourself or drop it on your foot. No such thing as fun without risk. Thanks for watching.